In this video, we're going to take a look at the pH of the stomach as well as the regulation of the pH in the stomach through different medications. So starting out, the stomach typically has a pH that is quite low, around 1 to 2. And so that is generated by the production of hydrochloric acid, which is a very, very, very strong acid. And that is in the structures and the lining of the stomach wall known as the gastric glands. And so this acidic environment is really important because it does help to kill most of the bacteria that's in our food if we do ingest it, and also provides the optimum pH environment for various different digestive enzymes that start the digestive process. So, for example, pepsin is a really great example here. Now, we can have issues that occur if we produce too much acid in the stomach. So, we do have a layer of mucus that lines the stomach and protects it from the damage from hydrochloric acid, because if we just had the acid, it would destroy our stomach. And so, we can have irritation to that stomach lining if we produce too much acid. And things that could contribute to producing too much acid are things like drinking too much alcohol, smoking, stress, as well as some anti-inflammatory drugs. For example, we looked at aspirin in a couple of other videos, and that is one that will lower the mucus production in the stomach. So the kinds of problems that can come and can arise from excess acid production are things like acid indigestion. So that's discomfort from having too much acid in the stomach. That can lead to heartburn, or it's also known as acid reflux. And that's where the acid from the stomach is rising up into the esophagus. And the other sort of problem that can arise from excess acid production are ulcers. And ulcers are direct damage to the lining of the stomach wall, which is going to result in loss of tissue as well as inflammation. So there are various antacids that you can take to help neutralize some of that excess hydrochloric acid in the stomach. And that's going to help bring the pH levels back down to the desired level. Most of the antacids we use are weak bases. They are things like aluminum hydroxide, magnesium hydroxide, as well as some of the carbonates. So calcium carbonate, sodium carbonate, and sodium bicarbonate. This is also baking soda, essentially. We don't use strong bases like sodium hydroxide or potassium hydroxide because they're too strong and too corrosive to body tissues. So essentially, they would destroy your esophagus on the way down to the stomach, and that kind of defeats the purpose of taking an antacid. So antacids, the way they work, they're pretty non-specific. They don't bind directly to any sort of protein receptors. They work simply by neutralizing excess stomach acid. So you'll take your antacid and goes into the stomach here, and then works to pick up any of those protons from the strong acid to help neutralize it. So this example here showing the bicarbonate anion picking up a hydrogen, and that's forming water and carbon dioxide gas. The rest of it goes down as waste through our system and out through our system. But keep in mind, this CO2, any of these carbonate type of antacids can produce a lot of gas, which is kind of uncomfortable as well. Now, some antacids contain something called an alginate, and alginates are really neat. When you take them, they don't look like anything, but when they get into the stomach, they're going to produce this alginate raft. And so essentially what it does is it floats to the top of the stomach, and it forms this raft that basically acts as a barrier to prevent any of the acid refluxing back up through the esophagus. Gaviscon is a really great example of this. And so it's really sort of a neat kind of reaction. If you go take a look for other videos on alginates and how they work, it's a really, really sort of neat thing to see. Now, I did say those carbonates that are antacids are producing carbon dioxide gas. And so some antacids are also going to include anti-foaming agents such as dimethicone. And what that does is it reduces the bloating of the stomach as a result of the carbon dioxide production. So it helps to get rid of some of this so that we don't bloat up as much and we don't have as much discomfort when taking antacids. So that is how the pH of our stomach works and how we can regulate it through some different medications. That's it for this video. We'll see you in the next one.